Hello guys, and today we'll review the transformation of function. So here you can see that I'm given an equation that represents all type of transformation. So, and you know the number a is always the vertical or stretch or compression. K is horizontal stretch and compression. D is your horizontal translation, and C is the vertical translation. So here the question is, say the transformation applied to the function, right? You don't know the function here, you have just to say the transformation. So first you will figure out what is a, k, d and c from the equation, right? So this is a is -1, that's k 1 over 3, and d is -4 because it's -4, right? And your c is -1. Okay, so when we'll say the transformation negative, when a is negative, it's reflected on x-axis, and if k is negative, it's reflected on y-axis. Okay, well here we have a, which is -2, it means reflected on x-axis, vertical stretch by a factor of 2, horizontal stretch by a factor of 3, right? When you say it, you flip k value. And then we have -4 mean 4 units to the left and 1 unit up, right? And remember one thing: if you are given a function and you can't find out a or k value in the function, or d and c, what you will do? For example, that's a new function. So here you can see that a is 2. You can't see a k value here, so it means k is 1, and your d is 3, and c is 0 here, right? So if you can't find out a or k, you write them as 1. But if d and c are not there, it means they're 0. It means no translation. Okay, in the next question, you are given a parent function, and you have to find the equation of the transform function. You can see the parent function is the green one, and you know that's a square root of x, right? And you have to find the equation of the pink one. And you can see that there's no translation, right? The only transformation is it's vertically either horizontally either stretch or compression. That's why we have to find the k value, right? So first we write the equation. So the equation will be, let's say, y equals kx, right? Now to find the value of k, what you will do, you will take any point on the function. Okay, so if you take that point here, you can see that x is 6 and y is 4, right? So this is my x, this is my y. So I plug in into the function here, right? So it becomes y is 4, k, x is 6, right? Or I can write 4 equals 6k. To find the k, I have to take square on both sides, so it will be 4 square equals 6k. So 4 square is 60 equals 6k divided by 6 divided by 6. So it means k equals 16 over 6 means 8 over 3. So therefore the equation of my transform function will be y equals 8 over 3 k. Oh, not k, x, I mean. X. Okay. Now I want to go over one more question here. If you are given a graph of some transformation and you have to find the equation, in the previous one you can see that there was no translation, but here we have a translation and there might be a vertical stretch or compression. So here you can always figure out how the graph has moved to the right or up, right? So here you can see that and you know that here the parent function is y equal x squared. So to find the equation, what I will do, first I will see that how my graph has translated. It's translated 6 units to the left and 2 units up, right? So my equation is basically y equals a x minus d square plus c. And that becomes a x minus d is 6 units to the left, so plus 6 square. And c is 2 plus 2, right? Now I take a random point on the graph again with the coordinates minus 8 and 6. So I plug in here minus 8 and 6, right? This is my x, this is my y. So that becomes 6 equals a. X is minus 8 plus that is x is okay, x is minus 8 and y is 6. Okay, minus 8 plus 6 squared plus 2, right? So here, and it's 2 units up. Okay, and that is minus 6. Okay, I plug in the values here. So it becomes 6 equals y is, let me just double check the values here. X is negative 8 and y is 6. Okay, it's translated 6 units to the left and 2 units up. Yeah, that's right. So that is a, and that is minus 2 squared plus 2. So 6 minus 6 minus 2 equals 6 minus 2 equals that becomes 4a, right? So it means 4 equals 4a. So it means a equals 1. Okay, I just want to double check here. The graph is translated 6 units to the left, that's right, and 2 units up, right? So it's 2 units up, and then we took a point that is negative 8, and x is negative 8 and y is 6. So when I plug in x is negative 8, y is 6, and plus 2, so that is my equation. So my final equation will be y equals x minus x plus 6 square plus 2. Okay, so that is how you can find the equation of a transformed function. Okay, in next question, we have in each case write an equation of the transform function, sketch the graph and state the its domain and range. Okay, so we are given an equation, the parent function y equals square root of x. It's compressed horizontally by a factor of 1/2, reflected in the y-axis, and translated 3 units right. And okay, so here there's nothing about the vertical structure compression. It means a is 1 and k is compressed horizontally by a factor of 1/2, so it means k is 2. Reflected on y-axis, it means k is negative 2. Translated 3 units right, so it means d equals 3, and 2 units down means c equals negative 2, right? Okay, now I know the key points for my parent function. So first I write the key points of the parent function. My function is y equals square root of x. So the key points, which are x, y, will be x is 0, 0, 1, 1, 4, 2, and 9, 3, right? And you know the mapping rule is, I'm writing the mapping rule here, x over k plus d, a y plus c. Okay, so here what I will do, if I plug in my values of a, k, c, d, k is negative 2, so it means x over negative 2 plus d is 3, and then I have a, which is 1, so it's just y plus c minus 2. Okay, now I use the points to figure out the new points, right? So when x is 0, it becomes 3, and y will be y coordinate will be negative 2. When x is 1, so it's 1 over negative 2 plus 3 and 1 minus 2. So that becomes 2.5 and negative 1. When x is 4, 4 over negative 2 plus 3, and 2 minus 2. So that becomes 4 over negative 2 mean minus 2, plus 3 is 1 and 0. Then I have 9 over minus 2 plus 3 and 3 minus 2. So that becomes 9 over 2 mean negative 4.5. So that is negative 1.5 and 1. Okay, so these are my new points, right? So, and normally it's better you graph the parent and the transform function. So first I graph the parent function. So here if I'll take the points, x is 0, y is 0, x is 1, y is 1, at 4 it's 2, at 9 it is 3, right? So that is my parent function. And now I graph my new points. So it's starting from x is 3 and y is 3 and minus 2. So that is the point. Then I have 2.5 and negative 1. So 2.5 and negative 1 is right here. Then I have 1 and 0 is here. Then I have negative 1.5 and 1, so it's here, right? So my new graph will be like that, right? Okay, and the coordinates of this point is x is 3, y is negative 2. So when you write the domain and range here, so the domain will be x belongs to R such that x is less than equal to 3, because your graph is on the left of 3. And the range will be y belongs to R such that y is greater than equal to negative 2, because your graph is above negative 2. Okay, so this is how you can graph a transform function. Next is the same, almost the same question, but a different function. So here my parent function is absolute value function. And now first I write the transformation, vertically stretch. So first write A, write K, and D, and C, right? It's vertically stretched by a factor of 3, reflected in x-axis, so mean A is negative, and translated 4 units left. So there's no K, so it's 1. 4 units left mean D is negative 4, and 1 unit up, so Z is 1, right? Okay, so now so mapping rule becomes, the mapping rule is x over k. So k is 1 plus d, so minus 4. A is negative 3y, and c is plus 1. So that is my new points. That rule will give my new points. So first I make the table of values. Okay, so here my key points for my parent function, which is y equal absolute value of x. And here I will write x minus 4 and minus 3y plus 1. Okay, so you can start from minus 2 and 2, negative 1 and 1, 0, 0, 1, 1, and then 2 and 2, right? So if I take my values here, x is negative 2, so negative 2, I'm just directly solving it. Negative 2 minus 4 will be negative 6. Y is negative, so it's negative 3 times 2 is negative 6 plus 1 is negative 5. Then negative 1 means negative 5, and that would be negative 2. So 0 means negative 4 and 1. Okay, when x is 1, it's negative 3. When y is 1, it is negative 2. When x is 2, it is minus 2. When y is 2, it will be 5. Okay, and now I plot these points here on my graph, right? So I start from this one. When x is 0, y is 0, my new point will be negative 4 and 1. So x is negative 4 and y is 1, so that's the point. When x is then I go for that one, negative 3, negative 2. So negative 3 is negative 2, so here. And then negative 2, negative 3 and negative 2. Then negative 2 and 5. So when it's negative 2, it is, when x is negative 2, it is 5. 1 minute, it doesn't make any sense here. When x is, we started from 0, 0. When x is negative 4, oh, when x is negative 4, so let me fix that first. Okay, so when x is negative 4, y is 1, that's the point. When x is negative 3, negative 2, negative 3 and negative 2, then I have negative 5 and negative 2, then I have negative 2 and 5, negative 2 and 5 is here, and then I have negative 6 and negative 5, that's the point, right? So my graph will be, and you know that is reflected on the x-axis, so that is my new function. And if you write the coordinates of this point, that is negative 4 and 1. Okay, now I have to write the domain and range. So the domain will be x belongs to R, right? Okay, and the range is y belongs to R such that your whole graph is below 1. Y is less than equal to 1, right? So for that, you look at the y value, not the x value. Okay, so that's the graph and the parent function. And the last one is reciprocal function. So here, first I write my transformation. What is A, K, D, and C? Vertical stretch by a factor of 4, so A is 4. Reflection in x-axis, so it means A is negative 4. And K, there's no K, so it means K is 1. Translation 2 units left, so D is minus 2. And 3 units down, so it's minus 3, right? And if I write in my equation here, you know the equation is y equals A, K, x minus D plus C. So if I plug in here, my A value is negative 4. There's no K, so D plus 2 and minus 3, right? So here first is better if you draw your vertical and the horizontal asymptote, and you know the restriction. If I write the domain and range first, that will be a good idea. So my domain is x belongs to R such that x is not equal to negative 2, right? That comes from the restriction, you know. My range will be y belongs to R such that y is not equal to negative 3, right? That comes from here. And now if I just take 2 points on my parent function, so okay, so that is my parent function xy, where y is 1 over x. So I will take the point negative 1, negative 1, and 1, 1. Okay, x over k, there's no k, so x plus d, and my d is negative 2. Okay, ay, a is negative 4, y plus c, which is negative 3, right? So if I plug in that point, the first one, negative 1 minus 1 is minus 3, and that becomes positive 4 minus 3 is just 1. Okay, from 1, 1, 1 minus 2 is negative 1, and negative, if I plug in 1, negative 4 times 1 is 4, negative 4 is that, negative 7. Okay, now first I'll graph my asymptotes. Okay, asymptote is x equals negative 2. At negative 2, I have a vertical asymptote, right? So I draw the vertical asymptote here. And my horizontal asymptote is y equals negative 3. That's my vertical asymptote. Okay, and now I graph my points. When x is negative 3, y is 1. Negative 3, the point is here. My other point in when x is negative 1, when x is negative 1, it's negative 7. The point is here, right? And now if you graph your function, you know your graph should not touch these lines, which are the asymptotes. So the graph will be like that here, and this will be like that here. It's like here, right? So this is how we can graph a transform function when my parent function is a reciprocal function. Okay guys, thank you so much.